Assalamualaikum warahmatullahi wabarakatuh and a very good day to Doctor. Today we are from Group 2, consists of me, AMZAR, Nada, Ain and RABIAH. Will present to you our part 2 of project. Firstly, we have identified that this posture is the most critical posture that worker adopt when doing their tasks. The advanced era tool that is suitable to this posture is rapid upper limb assessment or ruler, because their tasks mainly involve their upper body part. So at the end of this assessment, it will shows the ruler score and state what is the condition that need to be do after that. For part A, the upper arm score is 3, while the lower arm score is 2. Then the wrist score is 2, while the wrist twist is 1. So based on this, the posture score A is 4. And then we need to add up all of the number and get the wrist and arm score. And then from the table C, we can see that the wrist and arm score is 8. So then for the part B, the neck score is 3, while the trunk score is 4, and then the leg score is 1. So as the table shown, it is for the posture B, the score is 5. And then we need to add up all of the number to get the neck, trunk and leg score, which is 9. So as you can see from the table C, when the wrist arm score is 8 and the neck, trunk, leg score is 9, the ruler score is 7. A ruler score of 7 indicate a need for investigation and the implementation of changes. So to address this, we need to conduct a thorough analysis of the task considering worker body posture and their feedback. So we need to identify the main root causes of this ergonomic concern and develop a practical recommendation focusing on changes of workstation or procedure.
This is our fishbone diagram, the root cause analysis of our problem related to occupational ergonomy issues, which is human, machinery, environment, and management. Root cause analysis of human is lack of skilled operators and inadequate staffing levels. First, lack of skilled operators. The absence of operators with expertise in both coding processing and workspace design result in suboptimal workstation that do not adequately support task and operating well-being. Second, inadequate staffing levels. A shortage of personnel may result in rushed decision making during the design phase or limit the ability to gather comprehensive input from operators. Next, root cause analysis of machinery is inadequate handling equipment and age of the machine. First, inadequate handling equipment. Inadequate handling equipment not tailored to the specific demands of processing, thus impact workstation efficiency and creates ergonomic challenge for operators. Second, age of the machine. The age of machines, particularly older equipment, further limits workstation design possibilities as this machine may lack modern features and safety standards. For environment, inadequate workspace design and poor ventilation or dust control. First, inadequate workspace design. If the design of workstation lacks proper planning, organization, and ergonomic consideration, it can result in congested, uncomfortable, and inefficient work areas. Inadequate workspace design may lead to challenge in workflow management, hinder collaboration, and impact the overall well-being and productivity of operators. Second, poor ventilation or dust control involving the handling and processing of materials may generate dust particles that, if not adequately controlled, can pose health risks to workers. And lastly, root cause of analysis management is ineffective leadership and insufficient emphasis on safety and environmental. First, ineffective leadership. If leaders lack the necessary skills, knowledge, or commitment to prioritize and oversee effective workstation design, it can result in a disconnect between organizational goals and the practical needs of the workforce. Can lead to a lack of direction, coordination, and support for initiatives aimed at optimizing workspace. Second, insufficient emphasis on safety and environmental. It can lead to workspace that do not meet regulatory standard, compromise employee well-being, and contribute to environmental impact. This lack of emphasis may stem from a prioritization of short-term production goals over long-term consideration.
Hello, my name is Nada. I will continue the presentations. We have revised proposed design with actual worker and received feedback from the factory. All designs have garnered positive feedback from the factory with the exception of few specific elements. First, the proposal to restructure the strip base, which was not featured in our presentation video for the cowling milling machines. Its highlight commendable and it enhanced the ease of cowling pouring for operator without necessitating extensive movement. Second, the utilization of a vacuum suck lifter machine is deemed unsuitable. Primarily because the suck contains kaolin and the powder in the kaolin may lead to damage the vacuum suck lifter machines. But the application of the vacuum suck lifter holds significant importance in our proposed design. It's offer efficient and safe suck lifting. So we have proposed new solutions for design or layout in the processing area. We add single grinder overhead crane with hoist and position within the processing area, and the crane and hoist can move freely in the purple area only. Then the position of the machine is changed from vertical to horizontal, and we add half-cut pyramid hopper in both sides of the machines. We use 3 heavy-duty copper clips to secure the suck before liftings. We clip 3 pipes at the corner of the sucks. The worker controls the crane and hoist using controller. Step of process cowling for new proposed solutions. First, the worker can utilize the hoist control device to maneuver and position the hoist to the suck area. Second, the worker lower the hoist using the controller until the chain and clip can easily reach the sucks. Third, the worker securely fasten the corner of the suck using 3 clips, then verify that the clips are correctly positioned. Fifth, the worker controls the hoist to transfer the securely fastened suck to the hopper. 6. The worker used the hoist to place the suck securely within the half hopper, ensuring proper alignments. 7. Without removing the clip, the worker cut the suck and pouring its content through the half-cut side of the hopper in hanging position for optimal material flow. 8. The worker must maintain a balanced posture during the pouring process, avoiding excessive bending or twisting of the torso. Last, after pouring, repeat step 1 to 8 until the process is complete. Before lifting another suck, the worker must remove the empty suck before clipping the new ones. That's for me. Thank you. Next is the relationship based on anthropometry, biomechanics, and physiology. For the anthropometry, it is designed for average. The crane helps for a small size of worker to lift and move sack from one place to another place, and it is adjustability because the remote control used to adjust the movement of hoist because the height of worker are different. Next is biomechanics, less energy used for doing tasks, and it can reduce musculoskeletal disorder against worker, and it can increase the balancing because the weight of sack is exceed from the limitation of manual handling based on initial era checklist, and it can reduce forceful exertion because the old design the worker need to bend more than 90 degrees. The new design it reduce more than 20% of weight while doing tasks. And the last is physiology. It reduce movement because less movement of worker may help to performance and productivity and reduce irritate lungs. The disturbance of cardiovascular system may affect the performance of the worker. Thank you.